with variance and standard deviation. So population parameters is basically your proportions. Okay? So we are going to use decimal a lot in 6-3. Okay? So, I don't know if y'all remember this, but little p is the probability of success. Does everybody remember that?
Yeah.
So, when we go to write confidence intervals, we're actually using p hat, which is just the number of successes divided by the number in the sample. Okay? So it is the probability of a success happening. It is just little p. Okay? It is just little p. So, Q. Do y'all remember what Q is?
It's the probability of failure.
And how do we always figure that out? 1 minus what little p is. Does everybody remember that? In this situation, we call it Q hat. Because it has a little hat on it.
Can we just call it
Okay. So, we're going to find the point estimate for P. In a survey of 1,000 U.S. adults, 662 said that it is acceptable to check personal email while at work. Find a point estimate for the population proportion of U.S. adults who say it is acceptable to check personal email while at work. So we want to find little p hat. So this is pretty easy, okay? It's the probability of successes, so it's 662 over 1,000, because that was the total number of people surveyed. So what would that equal? 0.662, and that is your point estimate. So that is the p hat. That's all you have to do.
This one?
Nice.
We're on the first page.
Now we go to the next page.
Yeah.
No, it really it's almost. Alright, so I just had a switch right there. Okay, so guys, are you ready for the next one?
Yes, ma'am.
Okay. Confidence intervals. So every time we do a confidence interval, we know that we have to find E, right? Your error, your margin of error. In order to find E here, you find your Z confidence and you multiply it by the square root. You multiply it. Guys, defines the error. You multiply Z, the confidence of whatever Z is, 90, 80, whatever, times the square root of P hat, Q hat divided by N. And you all know how to find all of this, right?
Yes.
In that last example, what was N? 1,000, right? It was the number of people total. Do y'all remember that?
Yes.
Alright, so, in order to find error, that's how you find it here. So, these are your steps when finding your confidence interval for populations. Okay, it's population proportions. So, we know how to do all of this. So, let's do an example. Same thing. In a survey of 1,000 U.S. adults, 662 said it is acceptable to check personal email while at work. Construct a 95% confidence interval for the population proportion of adults in the U.S. Who say that it is acceptable to check personal email. So, P hat, we already found it, is 0.662. Q hat is 1 minus that. So what do you get? 0.338. We need to know what N is, and N is 1,000, correct?
Yeah.
And the last thing we need to know before we can do any of this is Z of 95.
That's 1.96.
1.96, right? On your chart, it tells you that in that little chart at the bottom. So then, the first thing you do, okay, is error. We need to find our margin of error. It is your Z, 1.96, times the square root of P hat, 662, times 0.338, all divided by 1,000. So you need to find this number first and then multiply it by 1.96. So, what is 0.662 times 0.338 divided by 1,000?
Well, once you square root it.
And then you'll square root it.
Oh, I'm getting scientific notation.
2.23756 e to the negative.
So now multiply that. Did you already take the square root of it?
The square root is 0.014.
Okay, now multiply that by 1.96.
0.0293.
So 0.029. I'll take that.
Okay.
0.029. 3 decimal places should suffice, unless your homework says 4. Right, Haley? Or if it says 5 and you get, or if it says 4 and you give 5, that's wrong too. We found that out today. Huh,
So
Haley?
you have to put the exact.
Whatever it tells you to. Yep.
Yeah, I got pretty mad when I put 1.7 on my homework, and then it was like, you need 1.70.
Yeah, 2 decimal places. So, guys, all you do now to find your confidence interval is p hat minus this, p hat plus this. So what is 0.662 minus 0.029?
Wait, what are you finding?
0.633.
0.633?
Yes.
Diego, I'll answer your question in just a second.
Yeah, we're good.
And 0.662 plus 0.029.
Oh,
So add and
okay.
subtract.
I got it.
Huh?
0.691.
0.691. And that is your confidence interval.
Never mind, I got it. You don't need to explain it.
Do you?
Yes.
Any questions?
No. Continue.
Is this one pretty easy?
Yes.
We'll go with that.
I'm gonna wait for the notes to end.
It is all the same, right? You're taking
Oh, so
like
it's just
either
p
your
hat
mu, your
plus
mean, or your p
E
hat,
and minus
adding
E.
and subtracting the error,
Okay.
correct?
Yes.
Every time.
That was good.
No, I'm you.
All right, so now,
Regular disc.
if I want to find the minimum sample size, it is n times p equals p hat times q hat times z sub c, so whatever your z chart is for your confidence, divided by your error, all squared. Okay, you're just going to use that formula if I want to find the minimum number in a sample size. If p hat is not given to you, if it is not given to you, you assume this. If it is not given to you, you assume this. If it is not given to you,
You assume that.
you assume it.
Yes.
Hey, do you assume that if it's not given to you?
Make sure.
You and me.
Do what? If it is not given
Yeah,
to
I'm
you,
doing it for Kelly.
you assume
Huge change.
this.
She asked me to.
When I what?
When you repeat it like that, it actually really helps. 'Cause then
So
it-
now, hold up! Hold up! You are running a political campaign and you wish to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum sample size needed if no preliminary estimate is available. So that means p hat and q hat are not given to you. 0.5. So that means we know that p hat is 0.5. We know that q hat is 0.5. Error? What's error?
No, figure that out.
It tells you.
0.03.
0.03 because it says 3%. What else does it give you up here? Your confidence is 95, right? 1.96. Do y'all see where I'm getting all of this out of the word problem?
Yes.
Hopefully. Who just said hopefully?
Not the 0.5.
Not the 0.5?
Because it doesn't say.
Because it doesn't give you an estimate, you assume it, like I said on the previous slide.
That's why she outlined something.
Because we assume it's always a 50-50 chance if we don't know what the actual proportion is. Yeah, it's a rule.
So
Yeah.
how do you know that the error is that 0.0?
Because it says up here,
I mean, I see the.
and what must be accurate, must be accurate
Within.
within 3%.
Okay.
I think you're saying accurate wrong, but I think it's right. Okay? So,
So how do we get into the
now how we find this is you just know that n equals p hat times q hat times 1.96 divided by 0.03 squared. So where do you start when you solve this? 1.96 divided by 0.03 squared. You do that first.
Got it.
And then you multiply that by a half and then another half.
1067.11.
What?
Yeah.
That's what I got.
Yeah.
Oh, I was about to be like, dang.
I think you're wrong.
Did you get that too?
So if it's people you run up
So
on
1,000
168,
Hold up. 1.96 divided by 0.03, enter, squared, enter,
106.
times 0.5 times 0.5. Yep. But it's people, right?
Yes.
So it's 1068.
Yes.
I'm sorry, I just wanted to check you. That seemed kind of high. But I think I'm remembering 6.4 notes and not 6.3.
Everyone looked at me like I was stupid.
Well, okay, so. Oh. No, I'm not saying you are. I'm just saying.
I said you.
Now,
You did the same thing. just-
we are going to tell you that the preliminary estimate gives that the p hat is 0.31. So p hat is 0.31. What is q hat then? 0.69. We already know that
Nice.
error is 0.03. Are you seriously commenting on that when you're in
Yes.
high school?
No, I thought, no, I was thinking like data proposed probable, was that what it's called?
So we already know these two things. The error stays the same and the confidence stays the same. So we already know those two things.
Yes. So we just do the same
So
thing.
you do the same thing just with p hat and q hat being different. So now error or n equals 0.31 times 0.69 times 1.96 divided by 0.03 squared.
I got 913.
Hmm?
I got 913.
913.02, so it would be 914.
914 people, PPL. Now, again, you can have part of a person, so know what you're looking at, what your sample is that you're looking at. What else did I want to talk about with this? What? No, before. Ask your question.
It did not look at me now.
Okay, good. I think that's it. Do y'all have any questions on 6.3?
No.
Now that you've done 6.1,